Section 11.2b is about multiplying radical expressions. So now we're going to learn to do that just like we did polynomials. If I have something like 4 times the square root of 2 times 3 times the square root of 5, if you're going to multiply those, you have to understand two things. First of all, the numbers in front, the whole numbers, can be multiplied. 4 times 3 is 12. But those are the only two numbers that you can multiply by each other. Likewise, the square root of 2 can be multiplied by the square root of 5, giving you a square root of 10. But you can't multiply the 4 and the root 5 or the 3 and the root 2. You can't go mixing and matching. Whole numbers by whole numbers and square roots times square roots. So down here we see an example where there's parentheses. So what I'm going to do is I'm going to distribute the square root of 3. So we end up with root 3 times root 5 plus root 3 times root 2. Now you don't have to write that step. I'm just doing it so everyone can get an idea of what's going on. The root 3 times root 5 is root 15, and root 3 times root 2 is root 6. Now, are there any perfect squares in 15 or 6? The answer is no, so that's simplified. Same thing here, we're going to distribute the square root of 2, root 2 times root 2. Now, we have a 3 root 5 times a root 2. The 3 has nothing to multiply by unless you count a 1. And then 3 times 1 is 3, that's fine. And then we have root 2 times root 5, because you multiply the square roots. So here you get the square root of 4, which actually simplifies to just a 2. Over here you get 3 times the square root of 10, which doesn't simplify at all. So 2 plus 3 root 10. Some more examples of multiplying, but this time we have two binomials, if you will. So we have to use the FOIL method or the distribute method. So I'm going to distribute 4 to both of those. So 4 times 3, and then 4 times root 5. Then I'm going to distribute the root 5 to both of the terms also. So plus 3 root 5, I put the 3 out in front, and then plus root 5 times root 5. Again, I'm writing every step out just so you see what's going on. 4 times 3 is 12. 4 root 5 plus 3 root 5, those are like terms. So 4 plus 3 is 7 root 5. And then root 5 times root 5, if you remember, is root 5 squared, which will cancel. So we have a 12 plus a 7 root 5 plus just a 5. And now 12 and 5 are now like terms, which I can combine to be 17 plus 7 root 5. Next example, very similar. Distribute the square root of 2. So square root of 2 times the square root of 3 plus square root of 2 square root of 2. Then we'll distribute the square root of 3 plus root 3 root 3, and then plus root 3 times root 2. So let's simplify. Square root of 6. Root 2 times root 2 is root 4, which is just a 2, because that's what the square root of 4 is. And then root 3 times root 3 is root 9, which is just a 3. I also could have thought about these two middle terms a different way. I could have thought about them as square root of 2 squared and canceled the canceled the square roots, and square root of 3 squared and cancel them. I could have thought about it that way, but it really doesn't matter. And then plus the square root of 6. So now hopefully you'll notice a couple like terms. Now I say they're like terms, they're actually like radicals, so I probably should call them that. So 1 root 6 plus 1 root 6 is 2 root 6, and 2 plus 3 is 5. Here's a couple more radicals to multiply, but with these I'm going to try to remind you of some special things we learned back in chapters 8 and 9. One thing we learned about back then is if you have two binomials that are the same, there was a special pattern that they created. Remember, you square the first, you square the last, and the middle becomes 2 times the first times the last. That's called a perfect square trinomial. Well, that idea can be repeated here because these are just like these binomials. So we're going to take the first term and square it. We're going to take the last term and square it. And then the middle is going to be 2 times the first, which is square root of 2, times the last, which is 5. And then we can simplify. Square root of 2 squared is 2. Here, 5 times 2 is 10 root 2, and this is plus 25. Like terms of 2 and 25 make it a 27 plus 10 square root of 2. Now if you don't like that, if you don't want to use that special product, if you'd rather just distribute this or FOIL it, please by all means do that. The one over here, if you notice, they're the same, except their signs are different. And that special product, back in Chapter 8, was called the difference of squares. And this one I think is a little easier. All you have to do is take the first term, square it, the last term, square it, and put a minus sign. You might also recognize this as a conjugate that we learned in the last section also. So we'll take the first term, the 3, and square it. The last term, the root 7, we'll square that, and we'll put a minus sign in the middle. So 9 minus 7, because the square and the square root cancel, so here we'll get a 2.